Hey guys, welcome to CPM 2. This is Module 2, Lesson 3. We are still solving equations. We're going to review the addition and multiplication properties. Basically, what we are doing today is the same as what we have done the last two lessons. In Lesson 1, we were just doing one-step equations where we were using the addition property or multiplication property. In Lesson 2, we were simplifying, so we weren't moving things from one side of the equation to the other. We weren't doing the opposite operation. We were just simply combining. In this lesson, we're doing both. And so we have to know the difference of what an equation is, what an expression is, when do I simplify, when do I do the opposite operation. So these are going to get a little bit harder than what we did in Lesson 1, but same main concept is getting x or whatever variable by itself. So objective A, use the addition property and multiplication property to solve. So it says here, first, let's recall the difference between an expression and an equation. Remember that an equation contains an equal sign and an expression does not. So in the first lesson, there was a huge chart, not really huge, but there was a bigger table of examples. This one only has 2 examples of each, but you get the idea. An equation here has an equal sign. So you see an equal sign here and an equal sign here. On this other side, you have an expression which has no equal sign. So you just have terms being added and subtracted to each other, no equal sign. Now, we need to try not to confuse these two processes below on when we are solving and when we are simplifying. So for example, on this first one, example 1, it says simplify or solve. You simplify an expression, but then you solve an equation. So once we figure out which is which, then I know whether to simplify or to solve. So on this first one here, this is an expression. Because it's an expression, we are simplifying. So with this, these are like terms. You have 1x, you have 1x. What I mean by 1x is x to the first, not squared or cubed or anything like that. So add your coefficients. So 3 plus 5 is going to give me 8, and then bring down your like term of that x. Okay, so that is it on that one. On B, however, now since this is an equation, and I know it's an equation because of that equal sign, now I need to solve. I need to get x by itself. That's the goal. So, opposite operation. What's the opposite of adding 5 to x is to subtract it. And what I do to one side of this equation, I need to do to the other. So I'm subtracting 5 from the left, then we're subtracting 5 from the right. So 5 minus 5 is 0, so that cancels out. So we got x equals, and then over here, 15 minus 5 gives me 10. So if you notice here, the biggest difference is that equation, one you can solve for, but then the process. Notice over here on this equation, we're doing the opposite operation. So I'm not just doing 5 plus 15 because they're on different sides of that equation. But over here, what's going to happen is when you have this 3x plus 5x, a lot of times what's going to happen is you guys will do the opposite operation and subtract it, and you'll say 5x minus 3x is 2x. But if there's no equal sign, or if they're on the same side of the equal sign, then you're just simply combining. You're not moving anything from one side of the equation to the other, so don't do the opposite, just combined. So, over here, you have your properties again. Basically, you can add something to both sides of the equation, subtract something from both sides of the equation, multiply, or divide from both sides of the equation. Key word here is both sides. You can add or subtract from both sides. You can multiply and divide from both sides as long as it is to both sides. So, when we solve these every single time, the first thing you need to do is simplify both sides of the equation. After you simplify both sides of the equation, then we're going to do our opposite operations. So, you look over here on the left. Can I simplify an x plus 6? Well, no. Those are unlike terms, so I can't do anything to this side. So I'm just going to bring it down. Bring down your equal sign, but then look at this side. Can you simplify? Can I combine those? Yes, we can do 1 minus 3. 1 minus 3 is going to give me a negative 2. And so now that I have simplified, now let's do that opposite operation. So now the goal is to get x by itself. So what is going on with that x? Well, we're adding 6 to it. So what's the opposite of adding 6? That is subtracting. So I'm going to subtract 6 from the left. When I subtract 6 from the left, now that we're moving it from one side of the equation to the other, I also have to do that to the right. So now 6 minus 6 is 0. Those cancel out. So we've got x equals negative 2 minus 6. Those are the same sign. So we're going to add and keep the sign. So we get negative 8. Okay, and that's what this whole page is going to be. First, simplify, then do the opposite operation. You want to look at both sides of this equation to make sure you can, though. So I'll go ahead and underline both again. That's going to be the theme of today's lesson, both. So on B, look at the left. Can I combine a y minus 5? Nope. Unlike terms, one has a y, one does not. So I'm going to bring that down. So then look over here to the right. Can we combine a negative 2 and a negative 6? Yes, we can. So negative 2 minus 6, same signs, add and keep the sign. We get a negative 8. Now, goal is to get y by itself when we do that by the opposite operation. So what is happening to y? Well, to my y, we are subtracting 5. The opposite of subtracting 5 is to add it over. Okay, and I kind of jumped ahead of myself, but notice we're doing that each to one side of this equation. I'm adding 5 to the left, so that means I'm also having to add 5 to the right. So negative 5 plus 5 is 0. Those cancel. So we're left with y equals negative 8 plus 5. Different signs, subtract and keep the sign of the bigger. We get negative 3. Okay, same thing on C. Look at the left, look at the right. Can we simplify? So can I simplify on the right? Yes, we can on this one now. Because those both have a y, combine them. So 3 minus 7 is negative 4y. Bring down your equals and your 12. So now what's going on between that negative 4 and y? Well, y is being multiplied by negative 4. So the opposite of being multiplied by negative 4 is to divide by negative 4. And what I do to one side of this equation, I must do to the other side. So if I'm going to divide the left by negative 4, I must also divide the right. So negative 4 over negative 4, that's 1. So those cancel. So I get y equals 12 divided by negative 4. Those are different signs, so it's going to be negative. We get negative 3. Okay, on D, look what you can combine. Can I combine anything on the left? Nope, that's a Z and a 4, unlike terms. Can we combine on the left? Yes, we can. 11 minus 5 gives me 6. So that means I've got Z over 4 equals 6. So the goal here is to get Z by itself. So what's going on between Z and 4? Well, Z is being divided by 4. The opposite of divided by 4 is to multiply by 4. And what we do to one side of this equation, to keep this balanced, we must do to the other side. So 4 divided by 4 is 1. So we get Z, and 6 times 4 is 24. Now with E and F, we can actually simplify both sides, and so we need to. So we look at this side over here. On the left, what can I combine? I can combine my x's. So 5x, remember to keep that sign in front. So 5x minus 4x is going to give me 1x or just x. So then drop down your plus 2 and your equals. And then look at this side here. We can combine those. Those are numbers without variables. So 7 minus 19 gives me a negative 12. Different signs, so subtract and keep the sign of the bigger number. So then now the goal is to get x by itself. Do the opposite operation. So what's happening to my x? We are adding 2. So the opposite of adding 2 is to subtract 2. And in order to keep this equation balanced, if I subtract 2 from the left, we must also subtract 2 from the right. So 2 minus 2 is 0. Those cancel. So I'm left with x equals negative 12 minus 2. Same signs. So we add and keep the sign. Gives me a negative 14. F, do the exact same thing. What can I combine over here on the left side? We've got a y and a y, so negative 6 plus 7 gives me 1y again, or just y. So I have y, bring down your minus 1 equals. Then over here, 17 plus 2. We can combine that to get 19. So now get y by itself. So the opposite of subtracting 1 would be to add 1. And what I do to one side of this equation, I must also do to the other side. Negative 1 plus 1 cancel. That's 0. And so we're left with y equals 19 plus 1 is 20. So we had an extra step in these when we had to combine our like terms first. Now we're going to actually get to even more multi-step problems. So here are your steps for solving. If there are parentheses present, we need to use distributive property. We need to combine any like terms on each side of the equation. Then it says to use addition property to rewrite the equation so that the variable term is on one side and the constant term is on the other side. Then use multiplication property of equality to divide both sides by the numerical coefficient to solve. And then step 5, you can check your solution. So start at step 1. If step 1 doesn't apply, go to step 2. If step 2 doesn't apply, go to step 3, and keep going until you get to a step that you can use. So in this example 3, 5m plus 1 equals 46. Look at step 1. Do I have any parentheses? No. So I don't need step 1. Step 2, combine any like terms. So can I combine any like terms here? Nope. One has an m, one doesn't. So those are unlike terms. And then you only have one term on the other side. So step 2 doesn't apply. So then we're at step 3. Step 3 says to use the addition property to rewrite the equation so that the variable term is on one side and the constant term is on the other side. So, because I need my constant term on one side, notice here you've got your variable on one side. So that means I need my number, my constant, on the other side. So that means I need to take care of this plus 1 first. So what is the opposite of adding 1? That would be subtracting 1. And what I do to one side of this equation, I must also do to the other. So 1 minus 1 is 0. Those cancel out. But this time, I am left with a 5m. Over here, 46 minus 1 gives me 45. M is still not by itself. So now I have an additional step this time. So that's why it says to divide both sides by the numerical coefficient. So what's going on between 5 and m? Those are being multiplied together. The opposite of multiplying those together is to divide. So I'm going to divide this side by 5. And what I do to one side, I must also do to the other. So if I'm going to divide the left by 5, we also have to divide the right by 5. So 5 divided by 5 is 1. 1m is the same as m. And 45 divided by 5 is 9. Okay, let's try again. Here we have no parentheses, and I don't need to combine like terms. You can't combine like terms here. One has an x, one doesn't. This is just a term all by itself. So we're starting at step 3 again. Step 3, get the variable term on one side. My variable term's already on one side. You already have x over here on the left. So that means I need my constant, my number, on the right. So that means I need to move this minus 6 over. So the opposite of subtracting 6 is to add 6. And what I do to one side of this equation, I've got to do to the other side. So I'm going to add 6 over here as well. Negative 6 plus 6 cancel. So I'm left with 2x equals, and then 18 plus 6 gives me 24. We still don't have x by itself, and that's the whole goal. So what's going on between 2 and x? Well, those are being multiplied. The opposite of multiplying is dividing. And what I do to one side of this equation, I've got to do to the other. So if I'm dividing the left side by 2, I also need to divide the right side by 2. So 2 divided by 2 cancel, because that's 1. So we get x equals 24 divided by 2 is 12. Okay, on C. Now we're finally to a different spot in this one. Now step 1, if there's parentheses, use your distributive property. I've got parentheses, so we need to distribute here. So we're going to go 3 times 3x, which gives me 9x. 3 times negative 5, negative times positive is negative, so negative 15. Bring down your equals and your 10x. Step 2, combine any like terms. These are unlike terms, so I cannot combine. This is just one term by itself, so there's nothing to even try to combine with it. Now we're to step 3. Step 3 is the same as what we did on these first two up here. but we're kind of going about it opposite. If you notice that this step right here, we already had that variable on one side, so that means I had to get my number, my constant, to the other side. On this one now, I still need to get that variable on one side. My variable is on both sides. My number is over here. So because my number is over here on the left, that means I need my variable on the right. Okay, you want to split these up so that it looks like this step here where you've got a variable and a number. So we need to move this 9x over here, but you can't just pick it up and move it. You can't just do 9x plus 10x to get 19x. You have to do the opposite operation because we are needing to move across this equal sign. So the opposite of a positive 9x is a negative 9x. We're going to subtract it over. What I do to one side, we must also do to the other side. So 9 minus 9 is 0. So 0x is the same as it not existing. So I can bring down my negative 15 equals 10 minus 9 is 1. 1x is the exact same thing as x. So we got negative 15 equals x. And of course, if you don't like that, you can always put x equals negative 15. D is very similar. Step 1, distribute. So I'm going to bring down my 13x equals, and I'm going to distribute this 4 to everything in my parentheses. So 4 times 3 is 12x, and 4 times a negative 1 is negative 4. I don't have anything to combine. We cannot combine these two here. One has an x and one doesn't. So now on to step 3. We need to get the variable on one side, the constant on the other. So this time, my constant is already by itself over here. So that means I need my variable over here. So I need to move this 12x over here. You already have your constant by itself, so my variable needs to go over here. So the opposite of a positive 12x is a negative 12x. And what I do to one side of this equation, we must also do to the other. So I'm going to subtract that over here on the left. 12x minus 12x is 0, so that cancels. 13 minus 12x is 1x, or just x. And we bring down that minus 4, and we get x equals negative 4. Okay, on E, we have no parentheses, so I'm not distributing. So step 2, combine any like terms. So look at this side here. Is there any like terms to combine? Yes, we do this time. So I can't combine anything with this D, but we can do negative 10 minus 2. So I'm going to bring down my negative 2D. We said negative 10 minus 2 is negative 12 equals, can we combine anything over here? Yes, negative 8 minus 4 is negative 12. Okay, so now we're here. We need to get the variable on one side. Well, the variable's already on one side, so that means I need to get my constant on the other. So I need my number over here. My variable's already on the left. Get your number on the right. So that means I need to move this 12. The opposite of minus 12 is 2, add 12. And what I do to one side of this equation, I must also do to the other side. So if I'm going to add 12 to the left, I'm going to add 12 to the right. Negative 12 plus 12 is 0, so that cancels. So I'm only left with a negative 2d. Same sort of concept here, right? Just like negative 12 plus 12 is 0, this negative 12 plus 12 is also 0. Now, on the left side, we're just canceling it out because I still have something on that side. If I cancel this out, then I've got nothing over here. And so because of that, we actually do need a 0. Okay. Don't let that 0 kind of trip you up because we can still solve. Your goal is still to get that variable by itself. So the opposite of negative 2 times d is to divide. Negative 2 over negative 2 is 1, so that cancels. And I'm left with d equals. I'm actually going to go over to the other side, so I'll have room for the other. We get d equals 0 divided by anything is 0. Okay, and 0 is a number, and so that 100% works. On F, we have parentheses. Let me change colors too, since this is kind of all getting crazy. Okay, we have parentheses, so I need to distribute. So we've got negative 5 times x and negative 5 times 4. And so now bring everything else down. So I've got 2 minus 6 equals, and my negative 39. So that was step 1. Step 2 is to combine any like terms. So can I combine any like terms over here? Yes, those are just numbers, so let's subtract. So 2 minus 6 is negative 4. Can I combine anything on this side here? Yes, a negative 20 and negative 39. So I got negative 5x, same sign, so you add and keep the sign, we get a negative 59. So then step 3, you need your variable on one side, your constant on the other. Well, I already have my variable alone on the right side, so that means I need my number, my constant, on the left side. So, what's the opposite of subtracting 59? That's going to be to add 59. And what I do to one side of this equation, I must also do to the other side. So I'm going to add 59 over here. So negative 59 plus 59 cancel. So over here, negative 4 plus 59, different signs. So subtract and keep the sign. So we got 55 equals. I'm going to bring down my negative 5x. So now my variable is on one side, my constant's on the other. What's going on between negative 5 and x? Those are being divided. The opposite of division. Nope, dang it. They're being multiplied. I'm sorry, guys. What is going on between negative 5 and x? Those are being multiplied. That's negative 5 times x. So the opposite of multiply is to divide. So we're going to divide over a negative 5. Negative 5 over negative 5 is positive 1, so those cancel. 55 divided by negative 5 is negative 11. So that's what equals x. And just like this one here, if it really bugs you, you can switch that. Okay, but it's not necessary. All right, there is one more page here, and I'm sort of out of room. I'm sort of out of time. I don't know if you guys saw my alarm, but I'm supposed to go help in a class real quick. I can't really pause and put these together, so I'm going to go through this, but I'm going to go through this very quickly. You have some words here for addition, for subtraction, multiplication, and division. These are your little hint words. So example 4, you need to write each phrase. In an algebraic expression, use X to represent a number. These two here are the biggest differences that we've got to know. A number decreased by 7, a number is X. Decreased means minus, and then 7, that's 7. On this one, and notice this is in order, right? A number decreased by 7. I'm not switching the order. In fact, it has to stay in that order. However, on this one, a number subtracted from 2. Don't write this, but what a lot of times we want to do is a number subtracted from -2. This is not correct. The reason is when you see the word from, when it says from -2, that means that it has to be where you start. So we're going to go -2, and from -2, a number has been subtracted. So we have minus X. And so that's what this little helpful hint right here is showing you. When it says from, you've got to start from whatever they're saying. Okay, so for example, 60 subtracted from a number. There's that word again. Because it is from, we have to start with a number and subtract our 60. On D, twice a number increased by -9. Twice means to multiply. So instead of doing 2 times X, we need to get in the habit of twice a number just looks like 2X. Increased right here means to add. So plus a -9. Down here, these get a little E. On E, twice the sum of a number in 3. When you see this word here, of is sort of your hint for parentheses. Okay, so when, just like, from means that's where you're starting. When you see of, that means parentheses. So we have, after your of, that's where your parentheses come in. And the operation between these is what is right here in front of it. So twice means that we have 2 on the outside of parentheses. We have a number and 3. So X and 3, and then the operation is the sum. Okay, on F, the quotient of 5 times a number and 17. So, quotient means to divide. So I need 5 times the number together. 5 times the number looks like 5X. Quotient is divide, and then 17. Now, do those parentheses really do anything on this problem for us? No. So this isn't wrong. It looks a little neater if we do 5X over 17. Okay, but those do mean the same thing. G, 3 times the difference of a number and 11. There's that key word again, of. So of means parentheses around what's next. The operation in those parentheses is the keyword in front, and it's 3 times this. So it's 3 times, 3 on the outside, the difference, which means minus, of some number x and 11. And then lastly, the product of 5 and a number decreased by 25. So the product means to multiply. So between this 5 and a number, we're multiplying. So it means I've got 5x in parentheses. And then we are decreasing by 25. Decrease means minus. So minus 25. Now again, just like with this parentheses here, it doesn't really do anything specifically that we need to absolutely keep it. So this is the same as just 5x minus 25. Okay. Again, this is the same as this. Either are 100% acceptable. So, sorry I kind of rushed through these last ones, but as you can see, I don't know if you can see, it's 1:16. I'm already 6 minutes behind. So, let me know if you have any questions. Pause and rewind, especially if you have any questions over this last page since I blew through it.